Interviews can be daunting, but they don't have to be if you're well prepared. In this course, Richard breaks down 10 popular iOS developer interview questions and demonstrates the solutions step by step.
In this video, I'm going to go through the top 10 iOS developer interview questions and not only go through them and solve, but actually we'll dive deep into the reasoning behind the answers and probably look into some documentation as well as look at some sample apps and sample code. And to assist me to make it look like a real mock interview, my friend Daniel will be helping. He's on the other side of the call. And Dan, say hi.
Hey, what's up, everyone?
So yeah, the first question would be to you actually. And could you tell me more about yourself?
Yeah, so hey everyone, my name is Daniel and I'm a web front-end developer working mostly with React. And I did iOS like 5 years ago for a little bit, so I am a bit familiar with the questions, so I can assist Richard with the interview.
So you'll be my interviewer now. Yeah, basically, so you've seen the question list. What do you think of them so far?
Yeah, it's like nothing has changed much. I'm just wondering why you didn't add any SwiftUI or combined questions.
Yeah, I think it's a good idea. I think SwiftUI and Combine as such are new topics, and they really worth a separate video on that topic. So probably we'll make a separate one, and not to miss it, just make sure to subscribe to my channel. And if you want the Combine and SwiftUI separate video, just let me know in the comments below. I'll make one just on that topic. Yeah. But why I started with those questions, basically they are very fundamental, and all the companies right now are asking some sort of them when interviewing for an iOS developer role. And this is really interesting because if you watch this video till the end, there are about 10 questions. It's very likely that you'll get one or two of them in your next interview. So I think that's a very good training and exercise for preparation for interview.
All right, yeah, so let's get started.
Yeah, let's go. I'm ready.
Yeah, so the first question is, can you explain me what is a view control lifecycle and what are the most important events?
Yeah, I think this is basically the classic iOS interview question and is being asked for 10 years at least. So to actually see what is a view controller lifecycle is, I've just created this basic app which is printing out each method so that we can see what's going on in the view controller while we show it or hide it. So I used the storyboard and created a very, very simple app which will show just the model view controller, basically presenting a sheet from the bottom, and we'll see what events we'll be printing out. Let's run this app and see for ourselves and what are lifecycle events and what are the most important ones. So open lifecycle, press the button, and we start with a view controller. So as you can see, the first one to be called is init with coder, which is basically an initializer, and in that case it might be called a different one in some cases, because for example, if you're initializing your view controller programmatically, init with frame will be called, or this one init with nib name or nil. So one of those, basically the initializer is always going the first. The next one is load view, which is a method when asking for a view to be loaded, and the view.load follows it immediately. Basically, once the view is loaded, you get the view.load event. I don't understand why load view if needed is called after that. Probably it's some sort of legacy artifact, because it doesn't make a lot of sense. Maybe it's just to ensure that the view is loaded, but at this stage it does nothing. And then we have the so-called appearance and layout events. So view will appear is called before the view appears on screen, and the view will layout subviews is called before the layout pass, and then after the layout has been completed, we have the view did layout subviews. All of those are available to be overridden. And and once the view is about to appear, once the view already appeared, you have the view did appear. And once I drag it down, we have them in the reverse. So we have the view will disappear, and view did disappear, and the dinit is called last. In case you don't see dinit for some reason in your view controller, that means that you have a memory leak and it's still in the memory. So you have to work with the memory profiler. And one more important thing is that if we clear the console, that this view will appear and view did appear, as well as view did disappear, might be called multiple times. So if I try to dismiss the view, for example, and then I'll decide to pull it back, I have the view will disappear, but I never see the view did disappear because it's still on the screen, and we are going back, view will appear, and view did appear. So Apple actually has a very nice sample for that. It has a very nice chart. I'll link it. I'll link it in the description for sure. And understanding this chart is really crucial to understanding the view control lifecycle. So you basically have 4 states: appeared and disappeared, and transitions between them into multiple directions. So and what's important, you can move to appearing state and immediately move to disappearing state, or vice versa. This is usually omitted by all of the candidates, and they just think it's one-time event, and this is a big mistake. So these events might be called multiple times in the life cycle of the view controller, as we've seen. And of course, the one when rotation is happening is the view will transition to size with coordinator, and the same is called when, for example, you're on an iPad and trying to resize the view controller on a multitasking screen. So I think that's it regarding the view controller events. So hopefully you're satisfied with this question. What do you think?
Yeah, I mean, I didn't know that there are that many methods around the view control lifecycle, so it's also new to me. But what do you think? What are the most important ones to remember? Because there are quite many, and which ones?
Yeah, to summarize, really, it's all about grouping them into categories. The first one is the initializer. That's the main one. That's the first one. The initializer is the first, and then the deinitializer is the last. Okay. Then you have the view loading related callbacks: load view if needed, load view, and view did load. Those are the next step, and they are.
But which ones are the most important? Like which ones I guess? I
think the load view and view did load. So view did load is probably the most used one. I think if you create a template right now, it will be there. It will be included there.
Yeah. What's the difference between load view and view did load?
So basically, load view is so they are going in a very specific order, right? So you have the load view first, and then view did load after that. It's pretty clear. Okay. And load view is the one to override if you want to use a custom view. For example, if you want to have view equals UI table view. Let's see how it works. Like I'll make just this change, and let's see if I will have a different view there. I mean, I should. Life cycle button. It looks like, is it a table view actually? No, because probably I'm using the storyboard. That's why it won't really plug it in. So I don't know. But if I were to use, where is this? Dimming view, drop shadow. Can't see anyway. Life cycle. UI table view. You see it's here. Pretty cool.
Oh yeah.
So it's there. So yeah, load view is what you use to connect your custom view and override the default. But if you don't do anything, it basically adds a UI view here, like that, and you just can ignore it. Usually you don't need to override it. And view.load is when the view is loaded and you can do some customizations, for example, adding in sub-view or something else. So that's why I kind of prefer to group them by the purpose instead of like selecting the most important ones. And then we have these appearance callbacks. View will appear, view did appear, and view will disappear, view did disappear. So regarding the presentation, appearance, disappearance. And we can add a third class, which is to layout, related to the layout, transitioning to sizes, and so forth. So yeah, initializer, deinitializer, view loading, presentation, and layout. And I didn't even go into details like, for example, things like did receive memory warning, that's another one, or will add, add child view controller, did add will move to parent view controller. So there are a lot of callbacks to you think about, like apart from those. But basically, view controller is it's a very important class. Obviously, there are a lot of connection points to work with. So those I've listed are the main. And of course, this project is available on GitHub, so make sure to play with it. And I think the best way to learn about the view controller lifecycle is basically open the project and go through each of those steps individually and understand how it behaves, and instead of like just reading documentation. Yeah, so hopefully we can move to the next one.
Yeah, let's go to the next one. So I think this is the most common one.
Which one?
What's the difference between a struct and a class?
Yeah, it's a very common one though. So
well, let me try to answer it.
Yeah,
do you want?
Yeah, go ahead. Yeah, go ahead. What do you think?
At least I remember something about it. So I think the class is reference based and struct is value based.
Value based. What does it mean in practice?
Like in practice, like when you create an instance, you get like, I guess, a pointer to it if it's a class. And if you create an instance of a struct, then you get the value instead. So
yeah, but what if you try to modify the same class? Like, will it modify at the other sites which holding that reference or not, if it's with class?
And what do you mean if there's going to be another
like
class?
For example, if you pass class to multiple objects and then you modify something like a value at that class, for example, let's say point of the player, will it be reflected for each object who own that class, or will they act like independently?
Yeah, I think it's going to be like a singleton.
Yeah, well, yeah, it will be reflected for all. Yeah, that's the main. It's called reference based. But yeah, a lot of people are going into details, like, for example, saying that struct is always copied when you pass it, or saying that you like something details like you cannot extend struct, you cannot subclass struct, but you can subclass a class, right? But those are the problem with those answers, that they are not very they don't always hold true. For example, you cannot subclass a final class, right? And you can extend the struct using a protocol. And the most important thing, which usually all the people are not aware of, is that the struct might be passed by reference to. And for example, all of the collections in the standard library, like dictionary, arrays, and so forth, strings, sets, they use these optimizations to reduce the cost of copying. So if you try to pass the array, it will be actually under the hood passed by reference, and only when you modify it will actually duplicate the whole array, which is an interesting idea to know, like for iOS developer, when profiling for performance problems. And if you look at the iOS or actually Swift array code, you'll see that there is like a buffer, which is used like internal storage for an array. And when you try to copy that, a lot of functions are actually passed to they are passed to this buffer. And there are a lot of optimizations, for example, like mutations for copying and so forth, simply because it has to be faster for those optimizations. And this is doing the job of making it run fast. And from the developer's perspective, it appears as if the array is copied immediately, but in fact, it's doing this copy and write on the hood. So because Swift is such an optimized language and a lot of complexity is hidden from the developer. So yeah, my answer would be that classes appear to be passed by reference, have the reference semantics, and structs are appearing like they are passed by value, so basically copied. But they just appear like that. Those are only semantics. Do not make assumptions of what's going on under the hood. And I'll link those nice articles from Apple which describe the difference more like in practice. It's important to understand those differences. But basically, yeah, the main one is the value versus like having an independent instance, or in case of struct, or having the same instance shared memory in case of a class. And yeah, of course, you can have the identity.
Hey, Richard, do you have like an analogy how to compare a class and a struct? Like,
I think the class is more like a bank account. So whenever you deposit something to it and withdraw, it refers back to the same bank account. So let's say I put 1,000 there, I have 1,000. I withdraw 1,000, I have 0, right? But a struct would be like more like a bank statement. So I have the bank statement from today, which shows 1,000. I can get the same from tomorrow, which will be 0. And I can copy, I can remove it, I can pass it to someone else. There will be no, it will be like a different copy basically. So independent of my bank account, independent of everything. So I think that would be the best analogy.
Okay, nice.
So that's sort of the benefit why using structs might be a good idea, because you can pass them between threads, because basically it's copied. So you are not afraid of any sort of race conditions, mutations, because once you pass it to a different thread, the struct lives on its own and the class will still have that reference. And that's sort of the notion why they wanted to get rid of classes as much as possible and move into structs and move this protocol-oriented programming thing. I think that was the idea.
Cool. Should we move to the next one?
Yeah, let's go ahead.
So what's the difference between frame and bonds property of view?
I think it's important to figure out what they are similar. I have, again, a sample app here that will help us to figure out what they are and what they are not. So first of all, let's go to check the UIView class. So we can just take a look at it. And we have the frame here. And we have actually both, frame and bounds. And you can see they are both of type cdirect, which means they are essentially the same type. And you can set one for another. So that really makes them similar. But what's different is their semantic and the way they apply to, the way they use to. And this is the most important thing, the most important difference. And in short, it boils down to, if I launch the app, I'll just launch the app. So the frame is about the, they both, if we zoom in here, like if we go into the cdirect, they both have the origin, which is the starting point, and the size, which is basically the size of the rectangle. So they The difference is that in case of frame, the origin points to the position in its superview. So if the view is not added to a superview, there is no concept of frame, right? And the size is, well, it's clear. It's the size which it occupies in the superview. This is one of the important things we will get back soon. And with the rect, with the bounds, it's slightly different concept. So the origin relates to the content that the view is showing. So what piece of the content the view is showing in its frame. And the size is basically the size of that viewport, let's call it like that. So to sum it up, the frame is about position of the view, so size and origin in relation to its superview. And the bounds, it's the what portion of the content the view is showing. And I'll have a few examples to demonstrate this a bit further. So first one is the scroll view. The white one is the scroll view, and we have two views there, which are sort of showing how the view scrolls itself. And I'll try to drag it now a bit, so see how the bounds and the frame are changing. So as you can see, there is a frame and bounds, and I'll try to drag it to different directions. As you can see, if you can take close attention, pay close attention to the frame is actually always the same here. It never changes. So whenever I drag it, no matter, it doesn't matter. But the bounds of the scroll are actually changing all the time in both directions. So the size stays the same, 350 and 241. It's the same here and here because the scroll view size doesn't change, and the content size doesn't change, right? But the origin is changing. So that's how the scroll view scrolls and decides what piece of content to display. And one more thing, of course, we have the case when the size of the scroll view bounds also changes, and that's when you have, for example, pinch to zoom gesture. Then you will have your size increasing, and scroll view will basically zoom onto something. And then there is another demo which I've prepared, is more interesting probably. It's rotation. So the red rectangle is showing the frame, and the purple is showing the bounds. I'll rotate it a bit. As you can see, the area which this purple rectangle is occupying in its parent superview, it has to be rectangular. It's growing once I rotate it, but the content stays the same basically, right? And if we take a look what's going on under the hood, we'll get the same answer. So the bounds always stay the same. It's 100, 100 here, but it's the frame that changes, and as you can see, the numbers are very, very complex here. And yeah, because we are just rotating. And if we go to the official documentation, we see that if the transform property is not the identity transform, the value of this property is undefined, of the frame property. So it to be ignored. But in this case, it actually makes sense, I think, because you can see the frame of this view is larger, right? So it occupies a larger part of the parent view. So yeah, I'll briefly show the code which I wrote here. It's nothing fancy, just a regular view controller, and when rotation is being detected, I'll just rotate it on the same level as the actual pinch gesture or rotate gesture.
All right, that was a pretty deep answer.
Yeah, I mean, yeah, it's not like an interview question and answer. It's more like a bit more explanation. So yeah, to sum up, the frame of the view, it's what it occupies in relation to its parent view, to its super view. No super view, no frame. And bounds is how it positions its content in its own, let's say, canvas. So that's to be the summary.
So the bonds are always larger than the frame?
The bounds are always larger than the frame. I actually don't know. I mean, could it be that the bounds will be smaller than the frame? Well, let's see. Well, actually no. There is a thing called clips to bounds, you know, right? So if you you can clip to bounds, probably some of the subviews might extend to the bounds, right? And they will still be drawn. But if you set clip to bounds property to true, then it will limit to this bounds. So yeah, the bounds can be so the content might extend slightly further than the bounds. Yeah.
Mm-hmm. Okay. All right, let's go to the next one.
Yeah, let's go.
What is protocol-oriented programming?
Yeah, so protocol-oriented programming is a new or not so new paradigm which was introduced to Swift. And the main idea was to differentiate from object-oriented programming and to solve those problems that were introduced with object-oriented programming. And I have actually a keynote, a presentation about the type system of Swift. Actually, I'll link the video as well. And in short, if the Swift has a very strong protocol system. So you can have the classes, structs, and enums conform to protocols, and the protocols can have the inheritance between them. So there's a very, very flexible way to define relationship. And if I compare the Objective-C, the object-oriented language, with Swift, the way this relationship power can be expressed with protocols. In Objective-C, you had the, for example, NS number. NS number subclassing is a subclass of NS value, and which in turn is NS object. So, for example, there is such so there are such issues that you could compare the view controller with NS number. For example, if this number is equal to the view controller, which does make a lot of sense, and because they are the descendants of the same class. And in Swift, they fixed it by using a protocol. Basically, a protocol that can ensure that that the compared values are of the same time. So the protocol-oriented programming is the idea that you can detach the relationships of between of the objects from the objects themselves. And if an object satisfies some sort of constraints, some sort of rules, then you can embed this whole object into a relationship without writing too much code and like repeating it yourself over and over again for each different kind of object. Basically, that's the idea of protocol-oriented programming is separating the hierarchy of relationship, of interrelationship, and hierarchy of objects, of methods. And that's a pretty powerful construct. For example, you have a lot of power in the thing called retroactive modeling. Like you have, for example, the equatable protocol and the way the equal sign is defined, the equality operator. And the inequality operator is defined as the opposite of equality operator. So pretty cool. And you can compose the protocols so you can work on a very, very high level without touching the concrete types and develop software in a much, much more modular and flexible way. And yeah, so it's focused on the types and relationship between them. And if you have a new type created, you can quickly embed it into an existing relationship between them, and basically use all the power that you've already developed to have new types supported immediately. And I think the biggest analogy for me is using some sort of algorithm to capture the list of to capture the photos of the tallest buildings by using the map of the city and the list of those buildings. So you have to have a map and you have to have a list to go through each of those buildings and take a picture. The only thing that you have to care about is that your map and your list are of the same city, then you'll get the proper pictures, right? So the protocol expresses this whole algorithm without naming the city. Once you have a New York, for example, here, you can make the same for Barcelona, or you can make the same for, let's say, Los Angeles. You can have the same set of photos taken simply by having these two objects. And I guess that's the idea of it. What do you think?
Okay. Yeah, I mean, I see protocols are like kind of like interfaces. So I don't really remember that much of it. But your answer was pretty good.
Yeah. I mean, the most important difference, because we have the interfaces in Objective-C, the most important difference in Swift is that you can actually work only with protocols. You can combine them. You can express more flexible relationship, more concrete relationship, and between objects, and that will give you, let's say, more compiler support in while you develop. So you don't have to typecast as much because protocol already constrains that type to a specific subtype, and you know that it will be of that specific type and so forth. So you are getting a lot of type safety, but at the same time you have a lot of flexibility, which in the object-oriented languages like Objective-C was implemented with the dynamic dispatch, dynamism, and so forth. That's why you could compare like a UIView controller with a number or whatever. Of course, it will return a false, but you still can do that. And in Swift, it will just throw an error.
All right.
It will not even compile, I mean.
All right. Okay, but let's move on. So,
yep.
Grand Central Dispatch.
Yeah, so
the question.
Yeah, let's try to open the playground.
Yeah, let's talk
it's a nice
about
one.
that one.
Yeah, I like this question quite a lot. So I guess the task is to figure out what will be printed out in all of those questions. Let's start with the first one, right? Do you want to try to solve it?
I mean, when I look at that code, it's like, who writes this kind of code?
Yeah. By the way, before me write this code for sure, it's I written this code half an hour ago. But before we start with that, I highly recommend watching this protocol-oriented programming talk by Apple in 2015 WWDC, and I'll link it, of course. So it's more entertaining probably than this video, but it definitely takes a longer time to understand. So yeah, let's get back to this question. Yeah, I think the first thing to say in an interview, in my opinion, when you see this, is that this code should not really be written. And if you see this code, the best thing is to go back to the drawing board, figure out what should it do, and then write it from scratch by understanding the requirements. But that's the first thing. And if, for example, if you were to be interviewed by me, you'd get definitely some bonus points for that. And yeah, but what do you think? The answer is here?
So defer does things as the last stuff, and so the printf is going to execute first.
This one?
Yeah,
let's try.
And yeah, so yeah, so I think the next one is going to be the print E, because I think the defer goes in the reverse order.
Yeah,
so
this is a very important thing to remember. They go in the reverse order. So if this defer is called first, it will be executed last. And the defer statement, for those who don't know this, it's basically a way to work with a legacy API. For example, if you have some resource acquisition happening here and you want to clean it up immediately, instead of remembering to clean up in all those if cases you have in the code, you basically write, as soon as you log onto something, you write a defer statement immediately, and you'll sure that the moment the function is closed, that resource will be closed too, basically, yeah. So then this one is obvious, it will be the next one. Which one is the next after E?
Yeah, so it's going to be the one above it, so where the print B is.
Yeah, and in my opinion, just do this. So whenever you have something complex, just hide it here with the code folding, and then you can unfold those ribbons. So you see the F, make Xcode help you. Then you unfold this one, which is the next one, right? Makes it really clear. E, then we unfold this one, right?
Yeah,
because we go one level up. And what is the order here?
So it's gonna print B, the first one.
B, because it's the B, running the B here.
Yeah, then it's gonna go to the print D.
D, because the defer statement is deferred, right? We just hide it.
Yeah, it's gonna be executed sort of last.
Then D, and then we have C, because we are exiting this whole close, right?
Yeah.
And this is the last one. E. Oh yeah, let's check this out. I think I agree with you. F, E, B, D, C, A. F, E, B, D, C, A. Looks like we are correct.
Cool.
Yeah, cool. Let's tackle the next one, which is a bit more complex. And again, the idea is that this code should not go into the real system, into the real application. So it's better to refactor it than trying to decipher and understand. So what would be your approach?
So actually, how would you refactor a code like that from the deferred one?
Yeah, well, it's a syntactic code, so I don't know the purpose. I'll go back and look what this code is doing, and then try to restructure it. But yeah, we can actually. This is a good help. In the preferences, you can actually set up the code in a text editing. You have the code folding ribbon here, which will add you this ability to fold the code, and this is really convenient to solve this kind of tasks. This actually asked quite a lot in the interview for some reason. So yeah, just fold the ribbons and you can focus on what to be executed first. So yeah, how would you tackle this question?
Yeah, so DispatchQueue, let's go. So the first one that's going to print it is the A.
A, because it's the first in the...
first line of code. Then this DispatchQueue line gets executed, so it like creates a new queue.
Yep. It doesn't create a new queue, it just dispatches to a different queue, right?
Oh yeah. Well,
yeah.
Lower level stuff.
Yeah, yeah, sure. But it's an async queue, right? So
yeah, that's true. It's in the sync one. So okay, well, yeah, so it's a sync. It's gonna I guess go through this function first. So it's gonna
the whole thing
print the So
yeah, correct. We can just hide it because it's the async, right? So it's a separate queue. We just hide it.
Yeah. So yeah, the I is gonna be next.
Correct. And what else? So we now need to look here, right?
Yeah, so then it's gonna check out the async queue, and it's gonna print the B.
All right, pretty clear. I don't think I have any concerns regarding that.
Okay, and then there's the async queue, so it's gonna
skip this?
Well, put it on another queue, I guess.
So we are hiding this for now.
Yeah, so it's gonna go to the D, print D.
D, right?
Yeah, and then okay, so there's a sync, not async, but the
Yeah, that's
sync.
synchronous.
Yeah, and so they are in the same queue, right? They're
And
using
the main queue,
queue.
yeah.
Yeah, so
So first of all, what is the sync doing to the queue? What is the purpose of the sync? How is it different from this? Like you have two of those. You have the async here and you have sync. What's the difference between
yeah,
this and this?
I think it's gonna block the UI until the print E gets executed.
Well, it won't block the UI. It will block the execution. So basically,
Okay.
you go the B, then you go to D. This is scheduled, right? This is async. It just skips it. Then you have D, and then it goes to this line, and then it waits. Basically, it schedules this part to be executed on the main queue again, but it will wait until this finishes. While it waits, the main queue has. There is one more important difference. There are serial and parallel queues, right? So we know that main queue is serial queue, so it will execute the tasks in the order that we send to it. So it will not start executing this task before it will start. It will finish this one. So the C will be finished first, and then only it will go to E, right?
Oh, for real?
Yep, because it is serial queue, so it will take task by task. So it will not execute them in parallel. So it will not be able to. There will be no race condition between the C and the E.
So
this is very important. Yeah.
So even though there's the sync like method or like
Yeah, it is async, right? But you see it's been async in relation to this global queue, but then it sends it on the main queue, and it is scheduled there. So the task has been put to that queue, right? Now you go next to the printing D, and now the sync is again with relation to this queue, basically waiting synchronously while this whole thing executes on the main queue. And you're waiting, but it takes the first task, which is C, it prints C, and then it will print E.
okay.
Because and then it will skip further. So actually, I'm interested. I'm interested. Yeah, I think it will block the queue, right? So the H is still here, so it will not reach it, right? So this should be So then again, we're having the async thing, right?
Yeah.
So we are we are skipping this, right?
Yeah. So H is gonna be next.
H. Let's see. I'm not even sure myself, but I would agree with you. It's H. And now it's time to unwind the async.
Yeah,
So
then it's gonna be F.
F, right? H, I is already here, so F. How about G?
Well, yeah, I guess that's the only thing left.
I think it won't be printed out.
For real?
Yeah, look at this. Look at this. So we have the DispatchQueue main async. So basically, dispatch tasks and move on. Dispatch the task and move on. So the H is here. So dispatch the task and move on. But then inside that task queue again, scheduling a next task to be executed synchronously, right? Just in front of your current task. Because this one is still haven't finished. Remember, the main queue is the synchronous queue. It's the serial queue. It takes one task after another. So until it finishes executing this task, it can't start doing this one. So and because it never finishes this one, because it waits for this forever, this is called a deadlock. So basically the G will never be printed.
Mm-hmm.
And yeah, that's my opinion. Let's take a look. This is not an easy task, I would say, but let's see what will be in practice. And how? So A, I, B, D, C, E, H, F. And as you can see, the G is not printed, right? So we'll just zoom in on this one. Yeah, really interesting. So These are actually the questions are asked in the interviews. Like some of the variations of them, you might get a different one. You can get the guard let question, not necessarily defer or not necessarily dispatch, but the idea is the same. It's some sort of spaghetti code. I wouldn't call it something else, and they're trying to trick you into making a mistake with understanding of those intricacies, let's say like that. This is actually a very high level question, so very high complexity questions. So yeah, how was that for you?
Yeah, it was quite difficult.
Yeah, the last one definitely is a bit more complex than the first one. And I think because this tests so much, you need to learn about the synchronous versus asynchronous scheduling. You need to learn about the deadlock and serial and parallel queues. So there is a lot of things to dissect in this question in a way, even if it looks so simple. And the difficult part is that it's actually quite easy to mistake the sync from async. It looks almost the same. Like there is one letter difference, and you just can like make a mistake by not looking well enough, let's say.
Yeah, and I think it's quite important to make the code readable also for others.
Yeah.
So that, like if the guy leaves the company, the other one comes in and can.
I think this code is unreadable. If we have to spend like 10 minutes, and if it's asked in the interview, it's definitely unreadable. But it's a good thing to mention that, in my opinion.
Yeah, absolutely. But okay, let's go to the next one. So
yeah, let's go.
Could you explain what is MVC architecture and what are their main components?
Yeah, so the MVC architecture is actually pretty old, and the best way to learn about it is to read about the Apple's document, and I believe it's actually a retired document, so it's not supported anymore. So there are plenty of materials. There are plenty of materials, but the gist of it is that you have a separate classes for each of your components, let's call it like that. You have the model, which is defining the data layer and the logic of the app. You have the view, which is responsible for the presentation and for the user input controls. And the controller is actually linking those together. For example, the user presses a button, the controller gets that signal, gets that event, and then it does something to the model. And the model somehow doing some job, and then it notifies the controller about the changes. So basically that's the idea of structuring the app in a way.
Okay.
In iOS, of course, you have the view and the controller really, really closely tied together, so that they are view controller, basically a very, very, let's say, sandwiched approach, and the model is usually might be different because it might be a core data model, it can be a remote model on the server or something else. But yeah, this is usually the architecture of the UIKit iOS applications.
So is the controller only used for UI, or could it be used for like data fetching and stuff like that?
No, not really. I think the first which I remember is actually the fetch results controller. I don't know why I'm looking at the Objective-C, but I think that there is a Swift version of it. So, of course, so the fetch results controller is basically having a fetch request to core data, basically responsible to preparing the data to be displayed to the table view. So you have like a table view controller, fetch results controller, and you combine them together, and you basically got your data showing up in the table view. And that's more like the idea of this model view controller approach, to have the modularity, that you have the building blocks and you combine them together, and you have the ready working app. And fetch results controller doesn't have any UI classes in its import declarations, because it's just modal controllers called like that. And then there's a UI document, which is doing the same job essentially. Modal layer, modal controller layer for reading and writing documents for the both Mac and iOS. So not necessarily. UIView controller is the most known one, but it's not necessarily that you have. You can have the combining roles, like for example, both controller and view roles. This is a view controller. And then there is modal controller. So definitely you can have a different. As you can see, there is like a different controller objects, and there is not necessarily like it's not necessarily controls the view and the modal. There might be the controller can connect together different pieces. It can connect, for example, multiple controllers, like a navigation controller, for example. It doesn't operate on the view level, it mainly operates on the controller level.
All right. So how about like when you have modern apps, they combine a lot of different content on a single screen. How would you tackle that? Are you going to have like many view controllers? Like, yeah.
Yeah, I think I'll do that. So I'll just, instead of putting everything into one view controller, I will split the content, I'll split the responsibilities among multiple view controllers, and then I'll use something similar to a child view controller approach. So I'll add one controller in a way like you add a subview. I'll add the same way a controller on top of each other and have them handle specific responsibilities. And one of the examples is like, of course, there is an official guide for that, for making a custom view controller. But there are already so many of those controllers. Like navigation controller is one of the examples, and everyone is using it. And split view controller is doing the same job and doing quite a lot of work by adapting the interface to the iPad and iPhone and split view on iPad. So without even knowing what's the interface all about, it just has two controllers and coordinates between them. So I'll definitely go with this hierarchical controller approach.
All right. Clear. Let's go to the next one. So the weak and unowned keywords. So where are they used and what are they for?
So those keywords are related to the memory management. So if I take a look, for example, on the UI table view, if I just go to the UI table view, and for example, data source and delegate are both declared as weak, which means that it will not hold a reference to the data source. Basically, it will just use it, it will query it, but it will not hold the memory. So whenever the table view, whenever the data source has no references outside, or if it doesn't have anything else, it will be deallocated. And it's usually made so because the table view is a view, and that's why it has to have, let's say usually the controller provides the data, and that's why it has to have the delegate weakly held, otherwise we have this reference cycle. So usually when the weak is used during the reference, to break the reference cycles. And unknown is very similar to weak, so in the fact that it doesn't add the reference count, but so it will not hold the object strongly in memory, but the difference is that it will not be declared as optional. So you use usually unknown salt when you're 100% sure that it will never be nil, and you just want to like work around the compiler to make it a non-optional type, so that you don't have to like unwrap it all the time and so forth. Mm-hmm. Usually you can use that in closures, for example, or if you for example refer in the lazy closures in a lazy variable, or just an enclosure. You have to use either weak or unowned, so not to create a reference cycle.
All right.
Usually it's used with the delegates. Like usually all of the delegates in Apple platforms, they are connected as weak, so they don't hold the object they are referring to strongly.
So are there any exceptions when the delegate is not held weakly?
Yeah, there are some exceptions. For example, there's an SURL session. It's a very interesting case. The basic networking object on iOS, or URL session is, I'll just switch to the Swift version of it. And session delegate. And the session delegate, which is basically an object that receives the events from the session, it's a strong referenced. So you create a session, you set a delegate, but the session will hold its delegate strongly. And this is important because it might have a memory leak if you don't remember this specific case. And the task is very simple. I guess the intent was that you just instantiate this delegate and the session basically handles it. The only purpose of this delegate is to be held by the session. You don't really need anywhere else. That's why it was designed that way, probably. Because if the table view, if you think about table view, the table view is held by the controller, and the controller usually is a delegate. But in this case, like the session is the main object, and the delegate is just a additional behavior that you want to customize. So that's why it's okay to hold it strongly. But this inconsistency is really actually quite tricky, and if you forget about that, it's really easy to make some problems in the app.
All right.
So always refer to the documentation, whether it's a weakly or strongly held property.
Got it. Cool. How about the lazy keyword? When is that one helpful?
Yeah, it's an interesting one. Lazy is basically a lazy initialization, so that let's take a look at this one. I'll find the viewed load, for example, here. For page view control, I'll create something here. Lazy variable. What could it be? Another view. So, for example, you can use something to add like a customization here. So, first of all, it's really convenient to have something customized. Like instead of, if I were to create a let constant, let view2, it would be, I have to have it like that. And then I have to use a viewed load to configure it, but here I can just add all of the configurations here. And yeah, so the lazy one is used for mainly for calculating values that you might not need. For example, if you don't want to add another view all of the time, depending on some conditions. So like if random you adds a view, another view. So in this case, in some of the cases when this would be a false, another view will not only will be added to the subview, but it won't even be instantiated. So that will increase the performance of the app a bit. So that's one of the cases. And another one is that you have some customization here available so that you can sort of add a tag and so forth. So it's really convenient to add something that you will otherwise have to write in a method. So to keep it close here.
How about can the lazy keyword be used on the collections? Like
yeah. It can be used on the collections too. So if I create an array, then I have to create lazy. It will produce the lazy sequence, and then when I execute a filter, it will take it one by one, basically. So or map. So it will not go through each of those it will not execute the whole code for that, but it will execute it only when I need the values. So map, then map something else. If I do map like that to string, let me just try string init, then map and then double init. And if I take the first, this will only take the first value out of this. It will not map those. It will not touch 2. It will not touch 3. So if you have a really, really huge collection, this will be quite efficient to use lazy on the collections.
What if you remove the first? Would it still go through all?
What do you mean?
If you remove the last method?
I don't know. Probably it should not go through any of those.
Okay.
I don't know. The only way is to run, I think. Going to check it out. So probably it will be not even executed because it's just like a unused result. But well, let's see. Trying to figure out what this result is. So it's this lazy map sequence integer doubles. So what is this result? Lazy map sequence optional double, and the base sequence is 3 elements, right? So you have these 3 elements, 1, 2, 3, which are here, and the transform, which is like combined function, which is probably a combination of everything here. And let's try to execute the first. So we're getting the double here, right? So it went through this. And let's print out the result again. Yeah, so we have again. I'm not sure if it's actual caching, but as you can see, it didn't execute anything, but it will return you whenever you ask for it, whenever you ask for something.
Okay. All right, so let's go to the closures, and
I hope it's the last one.
Yeah, it is the last one. So
awesome.
Closures, there's those 2 keywords that always kind of, as a beginner, kind of made it difficult to understand. And one of them is the escaping keyword, and the non-escaping is the other one.
Yep.
Maybe there's another one as well, but I'm not sure. But can you tell me about what is an escaping closure?
Yeah, sure. There's another one, auto closure.
Oh, what?
Auto closure. But that's probably in a different auto closure, yeah. But that's in a different video. So yeah, I've added this simple class here to look at the escaping and no escape. So the difference is really simple. First of all, the escaping parameter applies not really to the closure itself, but to the closure as the parameter of the function. So and what it says essentially is that you can, it tells compiler that you can store this closure in some variable. That's it. Because if you don't have this escaping modifier attribute, you will have to execute it only in the scope somewhere here in the function as the part. For example, all these UIView, UIKit, completion handlers, they are executed in the scope, so they are no escaping closures. And of course, you can execute the escaping closure here as well. There is nothing wrong with that. But if it's a no escaping closure, you won't be able to assign it. So I'll just uncomment that, and I'll get a warning. Assigning a non-escaping parameter handler to an escaping closure. And if I try to, it's implicitly non-escaping. At some point in Swift, it used to be the other way around. So the default was escaping, and you had to add this no escape attribute to change it. But if I fix it, it will basically add the escaping. Not sure if it still has no escape. No, it does not. So this one is removed. Yeah.
Cool.
So yeah, escaping is the one you can store in the variable. No escape is the one you can't, and it's no escape by default as of Swift 5 something.
Okay, so like, are there any performance benefits if you kind of do non-escape?
Yeah, I think it has to do with the performance issues or with the performance optimizations, but I don't know the details.
All right. Cool, but yeah, that was all the questions I had, and I think you know pretty well all of them. So you definitely passed the interview.
That's good. That's glad to hear. I'm glad to hear.
Yeah. So yeah, great job.
Glad to hear. So yeah, I guess that was it. And thank you, Dan, so much for assisting me and grilling me through this interview. That was tough to say the least, and hope our viewers enjoy this as well. Yeah, I'll put the links. I'll put the links to Dan social media or YouTube channel if you decide to start one, and I think it would be a good idea. So.
Cool.
Yeah, hopefully that was entertaining. And if you want to have if you want me to make some of the videos on any other topic, like different interview questions, just ask them in the comments below. I'll go through all of them, and if there is something interesting, I'll definitely make a video with those questions and answers. So yeah, good luck in learning iOS, and subscribe to my channel. That's where the new content is going to be soon.
Cool. Bye-bye.
Bye-bye.